My roll number is 518. I'm from the Department of Computer Science and Engineering. Today I'm going to give a presentation on the topic called superconductor-based energy storage. Coming to the contents of the PPT, firstly I'll start with the introduction and then I'll discuss what basically are superconductors and then principles of SPES, that is superconductor-based energy storage, and then the working of SMES, which is the main principle behind SPES. And then we'll discuss the components of an SMA system and next the advantages, challenges, limitations, and applications of SPES. And then we'll conclude with the recent advancements and future prospects in SPES. Coming to the introduction of the SPES, energy storage is important. Energy storage is important to keep power systems running smoothly by balancing supply and demand. But traditional methods like batteries, pumped hydro, and flywheels have some problems. They lose energy over time, don't last long, and take time to respond when needed. So a superconductor-based energy storage (SPES) solves these issues. It uses special materials called superconductors, which have zero resistance, so they can store electricity without any loss and release it instantly without any delay when needed. This technology can improve power grids and make renewable energy storage more efficient and help in advanced applications by providing fast and reliable energy storage. Let's first understand what are superconductors. So superconductors are special materials that have no electrical resistance and when cooled below a certain temperature, this means electricity can flow through them without losing any energy. And there are four key properties of superconductors. They are firstly zero electrical resistance, that is no energy loss when current flows, and then a Meissner effect or magnetic levitation, which means expelling magnetic fields and allowing objects to float above them, and then critical temperature, that is represented by Tc, that is the temperature below which a material becomes superconducting, and then next the persistent currents. That means once electricity starts flowing, it keeps moving forever without failing. And next, the principles of SPES. So superconductor-based energy storage is based on superconducting magnetic energy storage (SMES) technology, and the core principles involved here are zero resistance, that is no energy lost, loss when electricity flows, and then electricity flows forever without fading. And then energy stored in a magnetic field. Unlike batteries, it doesn't rely on chemical reactions, and then cryogenic cooling required. That means it needs extremely low temperatures to stay superconducting, and then in an instant and charge and discharge. That means it can release energy in milliseconds. This system is highly efficient, allowing 100% energy transfer with no loss over multiple charge and discharge cycles. Let's now understand the working of SMES principle, how SMES works. Basic working process involved here involves three phases. That is, firstly, the charging phase, in which electricity flows into the superconducting coil, and then the storage phase. Here, the current keeps circulating, creating a stable magnetic field, and then the discharge phase. Here, the stored energy is converted back into electricity when needed. And then key components here are a superconducting coil that holds and maintains the energy, and then the cryogenic cooling system that helps to keep the system cold for superconductivity, and then power conversion system to control charging and discharging. And SMES provides ultra fast energy retrieval and does not degrade over time. Now let's explore the components of an SMES system in detail. Firstly, a superconducting coil, as I said before, it is used to hold energy as a magnetic field, and then a cryogenic cooling system uses liquid helium or nitrogen to keep the system cool enough for superconductivity, and then power conditioning system PCS. It converts electricity between AC and DC as needed. Vacuum insulation, it helps to reduce heat loss and helps maintain ultra low temperatures. And next, control and monitoring system. It helps to regulate current flow and keeps the system stable. And now let's see why SMES is better than traditional storage. Advantages of SPS. It can give nearly 100% efficiency because no resistance means no energy loss, and instant energy delivery. Charge and discharge cycles are very fast, and then unlimited charge cycles, no wear and tear, since it doesn't rely on chemical reactions um, as traditional methods, eco-friendly, no harmful waste, and unlike conventional batteries, supports power grid and renewals. That is, it helps stabilize electricity supply and store renewable energy efficiently. Now let's look at the challenges of SPES. Challenges and limitations of SPES. Expensive setup, like high cost. Superconducting materials and cooling systems cost a lot, and it requires a cryogenic cooling, like it needs liquid helium or nitrogen to stay superconducting. And then materials limitations. Um, Only special materials work at very low temperatures, and then scalability issues. Large scale use is still being developed. Um, Even with these challenges, SPS has a potential to change the future of energy storage. And now let's see its game-changing applications. And the applications of SPS, power grid stabilization, that is, it delivers instant energy when demand spikes. And next, renewable energy storage. It saves an extra solar and wind power for later use. And electric vehicles, EVs, that helps and enable super fast charging. Maglev trains and aerospace. It powers high efficiency transportation systems. High energy, high power applications, that is, it is used in fusion reactors and particle accelerators. And let's look at the latest advancements.